In this video, let us see about buoyancy and flotation. And here buoyancy is a phenomenon where the upward force will be acting on a body immersed in a liquid or gas. So when a body is immersed in a fluid, there will be upward thrust acting on the body. So how this buoyancy force is created? So this phenomena is called buoyancy, and the force that is the upward force or thrust that is acting on the body is called buoyancy force. So how buoyancy force is created? Due to increase in pressure with depth. We know that a point here and a point here. If you consider the pressure at this point, there will be that will be lower than this pressure at this point. So due to this increasing pressure with depth, the buoyancy force is created. Let us see how. So there is a prismatic plate here, and the depth of the top surface is S, and the thickness of this plate is H. We know that F is equal to WA into H bar. Here, this on the top surface, there will be a force acting of F1 is equal to WA into S, and from bottom surface and on bottom surface there will be WA into S plus H. And now by seeing this, we can say that this F2 force is greater than F1, since it is deeper than this F1. So F2 minus F1 is equal to WA into S plus H minus WAS. And now if I simplify this, WAS plus WAH minus WAS. So these two gets cancelled, and finally WAH will remain. So this is the buoyancy force that will be acting on this body, and we can write this as W into area into height, area into the thickness is volume of the body. So FD is equal to, and this W is of fluid. This is fluid, specific weight of fluid. So from this we can say that it is independent of depth. So buoyancy force is independent of depth and also independent of weight of the body. So it is independent of, we cannot say it is independent of weight of the body, it is independent of density of the body. Independent of density of body. And so what is buoyancy force? Upward force generated due to hydrostatic law. What is hydrostatic law? dP by dz is equal to minus W. This is what increase in pressure with depth mean. So what will be the magnitude of buoyancy force? Buoyant force acting on body is equal to weight of liquid displaced by the body. So we have seen that this will be, and this is weight of body immersed. So what does it mean? Let us see now. Here there is full of fluid. This container is filled with fluid, and if I drop any body here, there will be this much amount of liquid that will be fallen on the ground. So this much amount of liquid will be falling on the ground. So this weight, if you measure this weight of this fluid displaced, this is the amount of fluid displaced. If you measure this weight, that will be equal to buoyant force. So that is what it is referring to. And if this density is less than density of fluid, this will be floating. If the density is more than density of fluid, that will be sinking. And due to this sinking of this body, there will be amount of fluid that is displaced, and here FB is equal to weight of fluid displaced. And here what is the weight of fluid displaced? Sorry, what is the volume of a fluid displaced? Here volume of displaced fluid is equal to volume of body. And what will be here? Volume of displaced fluid is equal to volume of this immersed portion, volume of immersed portion. So this is the floating case, and this is the submerged case. In submerged case, volume of displaced fluid is equal to volume of body, and in this floating case, volume of displaced fluid is equal to volume of immersed portion, not the total volume of the body. So we have seen that a body can be floating or it can be fully submerged. So for what will be the amount of volume displaced? We have seen here fluid volume displaced is equal to body volume submerged. How much amount of volume of body is submerged in the liquid or fluid. So in case of floating body, we have seen that volume of fluid displaced is equal to fraction of volume body immersed. In this we have seen that this much amount of volume is the displaced volume, and in case of fully submerged, volume of displaced fluid is volume of body. Total volume of body is the volume of displaced fluid. So this buoyancy effect is discovered by Archimedes, and he stated a principle, that is Archimedes principle, which is defined as the buoyant force acting on a body immersed in a fluid is equal to the weight of fluid displaced by the body, and it acts upwards through the center of gravity of displaced volume. So this is what we have seen, weight of fluid displaced by the body. So the volume, a certain volume will be displaced by the body, and if you measure the weight, that will be the buoyant force. And where does it act? It acts upwards through center of gravity of displaced volume. And now see here, suppose there is a body, and here there will be pressure forces acting. As we go deep into fluid, the pressure forces will be increasing, and it acts normal to the surface. So the greater magnitude of forces are at the bottom. So there will be resultant buoyant force which acts upwards in direction. So there is upward resultant force due to this pressure forces, but also there will be weight of this body acting downwards, that is W. So weight acts through center of gravity of the body, and this buoyant force acts through center of gravity of displaced fluid. So what is displaced fluid? If I draw this, so this is the same body, same shape of the body, and this much amount of fluid is displaced here. So if we find the center of gravity of the displaced fluid, it will be here. And in this case, center of gravity of displaced fluid and center of gravity of the body. Center of gravity of body is G, and the center of gravity of displaced fluid is B. So in this case, these both are same only. This is because this density of the body is uniformly distributed. If the density of the body is not uniformly distributed, for example, say this body is heavier at the bottom, so here density is ρ1 and here density is ρ2. For example, say that density is ρ1 and density is ρ2, and let me say ρ1 is greater than ρ2 is greater than ρ1. So the center of gravity will be on the heavier side. So center of gravity will not be at the center. Center of gravity will be towards the heavier side. But center of buoyancy, that will be at the center of the volume of the body. This is because the fluid displaced has a uniform density. But in this case, the body does not have the uniform density. For uniform density, B and G are equal. Let me write this here. for a uniform density body, B and G coincide. So that is Archimedes' principle. So let us see now this for floating and submerged static bodies. What will be the weight of what will be the buoyant force? So in any case, what I mean by any case is the body should be floating. The body should be floating, either floating or submerged static body. What is meant by submerged static body is if there is fluid here and I placed a body here inside the liquid, and it should stay at that position only. It should not sink down. That is called as submerged static body. So here there are different cases. The body will float if the density of the body is less than density of the fluid. The body will be in if rho is equal to rho f, the density of the body is equal to density of the fluid, then it is submerged static condition. Submerged static, or it can also be said as neutral equilibrium. In coming section we will see about what is neutral equilibrium, and if density is greater than density of fluid, that will be sinking condition. So we bother about only these two conditions. This is floating. We bother about floating condition and submerged static condition. So in floating and submerged static conditions, so the weight of the body is equal to buoyant force. So weight of the entire body, not the submerged portion. The weight of the entire body is equal to buoyant force. So the first thing we have seen that volume of displaced fluid is equal to volume of body submerged. So this is what we have seen. And the next thing is weight of the entire body is equal to buoyant force. So both should be remembered here.